Based on survey conducted on more than 300 PV mini-grids in Indonesia, it is found that quality of photovoltaic array must be improved by good installation. Although ideally has a lifetime operation of 20 to 25 years, photovoltaic array may be damaged in its early time. It is mainly caused by bad quality of installation and not paying attention to minimum limit of quality. This video session will guide you on how to identify characteristics of photovoltaic array and things that affect its performance and durability. This video not only will show examples of best practices but also considerations in photovoltaic array selection and maintenance. PV array is an interconnected system of several PV strings with specific capacity. In PV system, PV array consists of PV module and its support structure. PV module is installed on support structure with previously designed and specified tilt and orientation. The module then is interconnected to other modules with specified parameters. There are two things that affect the energy production of PV array: irradiance and cell temperature. The higher the irradiance received by the cell, the greater the current produced. Whereas the higher the cell temperature, the lower the voltage produced. Based on these two things, to get optimum power output, the amount of irradiance must be kept as high as possible, while the cell temperature is kept as low as possible. When installing PV array, tilt angle and orientation, or azimuth, affect how much irradiance can be absorbed by a photovoltaic cell. Because the best irradiance is DHI, make the photovoltaic cell perpendicular to the direction of the sunlight. The angle of PV array installation is determined by the latitude of the installation, while the orientation is determined by the direction of the sun. Soiling and shading must also be avoided, as they will decrease the performance of the PV array. Soiling certainly happens. It has varying degrees of thickening speed. The dustier and drier an area is, the faster the soiling. A proper mitigation to avoid soiling when installing PV array is to install the array at a sufficient slope so that the surface of the PV module can be cleaned by rainwater. To keep cell temperature from decreasing performance of PV array, sufficient distance between ground and the PV array is required to allow air circulation under the module. Now, we know several factors that affect the power output of PV array, that are irradiance, azimuth, tilt angle, shading, soiling, and cell temperature. The pictures show good examples of installed PV array as it has no shading from trees, powerhouse, as well as other adjacent PV arrays. On the contrary, these pictures show bad examples of installed PV arrays that must be avoided. Shading or shadow on PV module, either small or big, will decrease the power output of PV module. In the long run, it will even shorten the lifetime of the module due to hotspots caused by uneven radiation reception. The minimum required distance between PV arrays, or D, mainly depends on the location latitude, the height of PV array surface or H, and time. It applies especially in areas which the sun trajectory changes significantly throughout the year. For area close to equator, the rule of thumb is that the distance is at least twice the height of surface. The pictures show bad examples of distance between PV arrays. A PV array consists of PV strings. A PV strings consists of PV modules connected in series. A PV module consists of PV cells or photovoltaic cells connected in series. Next, let us continue to learn the components of a PV module. The first one is frame, that is commonly made of anodized aluminum to avoid corrosion. Frame is installed at the end of manufacturing process. It functions to ensure the sturdiness of the module. Protective glass protects the photovoltaic cells from the external environment and ensures the sturdiness of the module. Due to its function, Protective glass has the highest proportion of total weight of a photovoltaic module. Encapsulant or lamination is the layer directly cover the upper and lower side of photovoltaic cell. It is used to prevent mechanical damage to photovoltaic cells and isolate voltage of photovoltaic cell from other module components. Lamination is commonly made of ethylene vinyl acetate or EVA. Photovoltaic cells or solar cells are the main component of the photovoltaic module. They are made of semiconductor material that captures sunlight and convert it into electricity. PV cells are connected in series to obtain higher total voltage through the busbar wire. Material used for photovoltaic cells are generally silicon, such as polycrystalline and monocrystalline. Backsheet or insulating sheet is made of plastic material to protect and electrically isolate cells from moisture and weather. Junction box is used as connecting terminal between a series of photovoltaic cells and load or other modules. It contains a busbar wire from a series of photovoltaic cells, cable, and bypass diode. There are several types of PV modules, such as polycrystalline, monocrystalline, thin film, and amorphous. The most used types are polycrystalline and monocrystalline because they have good efficiency and characteristics to environmental changes. Generally, characteristics of a PV module are located on the label placed on its back. Common main characteristics are max power, open circuit voltage, and short circuit current. They serve as references for engineers in designing a generator system by synchronizing them with parameters of other components. Parameters listed commonly are marked with STC or standard test condition, a standard condition that is set in such a way to have a fixed irradiance of 1000 watts per meter square and a temperature of 25 degrees Celsius and an air mass of 1.5. The STC certainly is different with the real condition because the irradiance value is different and cannot be controlled, so the temperature and the air mass are different too. The label also provides mechanical information such as dimensions like length, weight, and height, and weight per module. Another important thing written on the label is the module voltage and current coefficient for each temperature rise. This information can be considered when selecting a module for area with extreme weather. Some things to consider when selecting a PV module. First is efficiency. The higher the efficiency, the less land required to install PV array. Second is temperature tolerance, that is preferably less than 2.5% under STC. This information can be found on the datasheet or performance label located on the back of the module. Third is anti-corrosion. The PV module frame is commonly made of aluminum. You must ensure that its manufacturer has an anti-corrosion certificate. And lastly, the PV module is able to operate at voltage up to 1000 volts DC. Next, we will learn the steps on how to calculate required PV module capacity. First, measure and calculate the load respectively. Day load that is from 7 a.m. to 5 p.m. and night load that is from 5 p.m. to 7 a.m. Second, find and get the irradiance value or peak sun hour of the PV system construction point. Third, calculate the amount of energy needed in 1 day or 24 hours. Assume energy losses of an off-grid PV systems are 37.5% during nighttime and 22.5% during daytime. Required PV module capacity is calculated by dividing the total energy by the irradiance or PSH value. There are some common faults in PV module. Broken solar cell in a PV module shows a poor production quality. Broken cell tends to decrease power output of PV module due to the imbalance of output between cells. The best mitigation for this fault is to perform a visual check at the time of purchase. Snail trail can indicate a micro crack in PV cell. It is caused by formation of gas from the backsheet to the cell surface. The formation process of snail trail takes place after several years of exposure to the sun. Snail trail is believed to decrease the PV module performance. Broken glass is a big disaster. It certainly makes unwanted external objects, such as water, dust, and small animal to enter that will greatly decrease the PV module performance or even to the point it cannot be used anymore. The main cause of broken glass is improper handling during delivery or installation, as well as hard objects falling on the PV module. Sometimes we find PV module that has been installed for several years experiencing cracks on the backsheet side. The main cause of this fault is due to bad selection of components. Or to put it simply, the quality of the PV module is bad. Bad lamination and backsheet that is easy to break will allow water vapor to easily enter the PV cells. Junction box must be airproof and waterproof as well as have high IP rating so unwanted external object cannot enter it. But junction box will allow water and dust to enter, cause a short circuit, and then make bypass diode doesn't work. This condition will make PV module always in an open circuit. Frame selection must consider the strength of the wind so that it is not easily broken and causes damage to the module. To avoid and identify faults in PV module, do the followings. Establish a comprehensive quality assurance process at factory, such as sort out the bad cells. Carry out an electroluminescence check to identify poor soldering quality, micro crack, and poor lamination. And run mechanical load tests to determine the damage that may be caused by the vibration or load. Routine check must be done to check the PV module condition as preventive maintenance. A PV module consisting of bad cells must be replaced by the manufacturer during warranty period. Hotspot can be indicated by a visible spot that is caused by localized heat on PV cells, or in other words, difference in sunlight received among PV cells. Let us go into detail. The output from PV cell is proportional to the amount of radiation it received. Different cells' outputs will result in cells behaving differently, then create problem when connected in series. PV cell with lower output current decreases and limits the operational current of entire PV strings. This is made worse if the cell is completely closed and makes the power generated by other cells and the strings totally eliminated. Because there is limitation within the cells to overcome power dissipation, they can overheat, resulting in hot spots. However, the cause of temperature increase is not limited to only partial shading, but also poor cell quality, poor soldering between cells, and cells with low shunt resistance. Low shunt resistance can cause power loss in PV cell. So, how can we avoid hotspot? Early detection of hotspot can be done by routine temperature inspection on PV module surface using a thermal imaging camera. Connect bypass diode in reverse parallel with a cell or group of cells. During normal operation, when all cells are exposed to sunlight, they generate electricity. The bypass diode starts operating when one or more cells are shaded. Now, we are going to learn about PV interconnection starting from more detailed difference of PV cell, PV module, PV string, and PV array. It is as follows. PV cell is the smallest part of PV module that is generally box-shaped with 0.5 volts DC output. PV module is PV cells connected in series so that it has certain voltage with certain current. For example, 36 cells produce a voltage of about 18 volts DC. Its capacity is expressed in WP or watt peak. PV string is PV modules connected in series. PV array is a complete PV interconnection in a PV system. It can consist of several PV strings connected in parallel. What are things to consider when assembling PV modules, both connected in series and parallel? Assembled modules must be identical, that is, for their current and voltage characteristics. It is highly recommended that they have same brand and type. Total voltage and current of the system must respectively be in accordance with the specification of inverter and charge control. Modules are connected using MC4 socket. To keep balance, make the positive and negative cables have the same length. Install blocking diode if the power current exceeds the module's capable capacity. When several modules are connected in series according to the first Kirchhoff's law, current passing through the PV string is the same at each connection point. That contrary with the voltage, whose value increases as the number of modules increases. The picture shows a simple illustration of identical modules connected, each in series and parallel. Each series connection produces the same current, while its voltage and capacity are totaled. For parallel connection, voltage is the same, while its current and capacity are totaled. What effect will a PV system experience if the PV module is not typical and its specification doesn't match with the inverter or charge controller? Total performance of the system will decrease. In a PV string with different modules, its current will have the same value to module's current with the lowest specification. Total voltage of a PV module circuit whose value is less or more than the operational range of the inverter or charge controller will cause said power conditioner to malfunction. It even can cause fatal consequences such as permanent damage. Overcurrent based on inverter or charge controller maximum capacity will cause the protection system of the power conditioner to operate, that results in the system not functioning properly. If one or several are damaged, they must be replaced with new modules of the same brand and type as the existing. Regarding to cable installation, there are several things that can be done to improve its quality. Avoid coiled cables between positive and negative passes. Although the cable used is UV resistant and water resistant, it is better to also install cable conduit to support the cable against mechanical movement, such as when there is hard wind. It is highly recommended to use a pre-assembled or dedicated plug-in from the photovoltaic module manufacturer. Use connectors of the same model and type to avoid mismatch and bad connection. It is recommended to use MC4 connector with maximum resistance of 400 ohms. Connector must have maximum voltage rating of 1000 volts DC or more, and current rating that is higher than the short circuit current of the PV string. Use the correct connector size for the cable. Cable installation that is too large will cause water to enter the internal connection. Install the PV module within a string, in a configuration that its top side is placed on a line with other PV module's top side. Next, let us learn several common types of ground mounting system for PV module. Fixed tilt is ground mounting with fixed direction and tilt. What must be considered for this ground mounting type is the module position to the sun movement, as to get the right azimuth and angle. These two parameters can be obtained using simulation software such as PVSys or PVSol. Tracking system or single axis can adjust its tilt to follow the sun movement so that the module can get better daily irradiance. However, its weakness is that the construction and fabrication cost is higher. Carport is similar to fixed tilt type. The only difference is its foundations are lower in number but bigger in size. Double-axis tracking system is also applied. but very rare because of its much higher cost, both for the capital and the operational. Azimuth is the direction of the sunlight. PV module must be directed toward the equator in order to get optimal energy output. Since azimuth varies according to latitude and time in northern hemisphere, in which the latitude is above 0 degree, the optimal direction of the PV module is 180 degrees or facing south. In southern hemisphere or below equator, the PV module must be directed to north or 0 degree. The direction may deviate by up to 45 degrees east or west, without significantly reducing the energy output. Location coordinates can be determined using a handheld GPS. Once the latitude is known, the PV module direction can then be determined. Regarding to foundation characteristic, the recommendations are as follows. For solid ground, use concrete foundation. The recommended mixture is 1:3:3. For non-solid ground, like swamp or agriculture field, use piles. Prefabricated foundation can be used as alternative to get good quality and controlled concrete. This method can also speed up the construction process. Foundation construction has a minimum dimension of 35 cm x 35 cm x 60 cm, that is 2/3 of the height of the foundation buried in the ground. Some examples of bad foundation are using foundation other than concrete, for example, wood. Having the foundation size not in accordance with the mechanical frame, for example by having less area that will cause the anchor not to be properly installed on the foundation. Positioning the slab not in the middle of the foundation, that will cause the structure's legs to be unstable. Using bolts or anchors made of material that rust easily. Not attaching bolts or anchors properly to the foundation. Laying the foundation on ground that will potentially erode. And using poorly mixed concrete that will result in breakable foundation. There are also other things that must be considered in installing the foundation structure of the PV module. Install clamps both at the end and middle, with identical position and tightly. Clamps must not shade cells. Do not use cable ties to replace clamps. Rail installation must consider the distance between foundations. It should not be so far that causes the rails to support heavy load. In slope area, the piles must be supported by additional struts. Still in slope area, the structure should not be positioned too high, that will cause difficulties during maintenance. The last section in this video session is the maintenance. To keep PV array performing well, do maintenance as follows. Clean its surface regularly. The drier and dustier an area, the more frequent cleaning it needs. Periodically check and tighten the connection between modules. Keep vegetation under or around the array from growing taller and causing shedding. Use thermal imager to detect hotspot and replace any damaged module with a new one. Damaged module has very high temperature in contrast to other modules. Periodically tighten the structural bolts. You can pause this video while doing the quiz.